Hey there, and welcome to today's Explainer. You know, we live in a world that's just absolutely, completely surrounded by complex software. But today, we're going to peel back all those intimidating layers and look at the raw, elegant narrative underneath. Because, believe it or not, every single piece of software, from the simplest little app on your phone to the most advanced operating system, tells a story. It's got a beginning, a middle, and an end. So today, we're going to learn exactly how to read that foundational logic together. So to kick things off, let's just ask a super fundamental question. What exactly is programming? I want you to think about your normal daily routine for a second. You wake up, maybe check your digital bank balance, and later on you're ordering dinner through an app. Every single one of those seamless actions, that's the result of human desire crossing a bridge right into machine execution. It's pretty amazing. Programming isn't just about sitting in a dark room typing mysterious hacker codes. It's actually the very real process of translating our everyday problems into a language that a machine can actually execute. The reality of it all is actually remarkably simple. Programming is essentially just algorithmic decomposition. Now, I know that sounds kind of fancy, but it really just means telling a computer how to solve a problem using clear, logical, and highly sequential instructions. Think of it kind of like a super strict, unforgiving recipe. If you've ever baked a cake, you know that if you complete every single step perfectly, you get a delicious result, right? But if you skip a step or put ingredients in the wrong order, you end up with a total mess. Well, computers operate with that exact same rigid obedience. Let's put this into a little story. Imagine it's lunchtime and you turn to a friend and just say, "Hey, make me a sandwich." Your friend obviously understands your human intent. They intuitively fill in the blanks, walk over to the kitchen, find the ingredients, and bring you some lunch. But if you say that exact same sentence to a computer, it just sits there, doing absolutely nothing. A computer cannot guess your intent. There's no intuition. It's bound by absolute imperative logic, and it is completely dependent on you telling it precisely, step by step, what to do. So to actually get that sandwich from a machine, you really have to break the story down into its absolute most basic logical components. You literally have to explicitly instruct it. Step 1, get 2 slices of bread. Step 2, place 1 slice on a plate. Step 3, add the ham. Step 4, add the cheese. Step 5, place the second slice right on top. And finally, step 6, serve it. Without that unyielding, specific sequence of instructions, the computer is entirely helpless. Programming is really just the art of breaking a big, macro problem, like being hungry, into these tiny, totally manageable micro-instructions. Now, this whole need for sequential logic builds into the universal structure of pretty much every software story ever told. We call it the input process output model, or just IPO for short. And literally, every single computer program follows this exact simple cycle to function. Input is the raw information, that's the beginning of our story. The process is where the computer applies rules or calculations, so think of that as a rising action and climax. And the output, well, that's the final result presented to you, the grand resolution. Let's look at a couple of everyday examples to make this concrete. Take a standard calculator. You input 10 plus 5. The process happens totally behind the scenes where the computer adds those numbers together, and the output, boom, the number 15 flashes right back at you. The exact same narrative applies to a login system. Your username and password, that serves as your input. The system's process is quietly comparing those credentials against its stored secure records. And then it gives you the output of either a warm welcome or, a sudden error message saying, try again. The stakes get a little higher when we visit the ATM, right? But the core narrative remains completely identical. Your input is inserting your card, typing in your secret PIN, and requesting a specific amount of money. The process involves the ATM secretly communicating over the network with your bank's database to verify your available funds. And the out part is the physical dispensing of cash right into your hands. So that totally everyday action is entirely driven by a strict programmed IPO sequence running in the background. And remember our little sandwich problem from earlier? Well, when you use a food delivery app today, you're actually executing a massive IPO sequence just to feed yourself. Your inputs are your location and your chosen meal. The process is doing some incredible heavy lifting. It's calculating delivery fees, pinging the restaurant system, and assigning a driver. Finally, the output is that deeply satisfying live map tracking your rider right up to your front door. It's like magic, but really, it's just IPO logic. Okay, so we've explored the stories that software tells, but what about the actual authors behind them? What does a programmer's real day look like before their fingers ever even touch a keyboard? Well, spoiler alert, it's actually far less about typing at the speed of light in a dark hoodie and much, much more about deliberate planning and thinking. The reality of the job looks way more like a continuous whiteboard session with lots of coffee. Programmers spend an enormous amount of time understanding user requirements, designing the overall architecture, creating the algorithms, and collaborating with their teams. Writing the actual code, that's just one small fraction of the job. The real work is asking the right questions and mapping out the entire solution long before it ever gets translated into a machine's language.
And that brings us to busting a few myths. It's a super common misconception that programming is only for people who are absolute geniuses at advanced mathematics. In truth, it's really about systems thinking. Basic logical reasoning and problem-solving skills are vastly more critical than being a math whiz. Honestly, if you can optimize your morning routine or logically sort out the logistics of a complex family vacation, you already possess the exact foundational mindset required to engineer great software.
Here's another popular myth for you. People assume programmers have these encyclopedic memories where they memorize every single line of code. No way. The truth is, the most senior, experienced developers in the world spend half their day searching Stack Overflow or reading documentation. The syntax, like the exact spelling and punctuation of the code, is entirely secondary. Understanding the core concept and the logic behind it, that is everything. You can always look up a command. So, as you can probably guess, programming is definitely not just typing code. Typing is literally just the final translation step. True programming is an ongoing, evolving journey of planning, designing, testing, and debugging. The real programming happens in your head, on a notepad, or on a whiteboard, long before the computer screen even turns on. It's all about figuring out the story you want the machine to act out. Once you actually have all that logic mapped out, you simply pick your translator. Since computers only really process binary, ones and zeros, we use high-level languages to bridge the gap. You might use Python if you're working with AI or data, maybe Java for enterprise apps or Android, JavaScript to make the web interactive, or C++ for heavy-duty game engines. They are really just different dialects serving the exact same purpose, delivering your carefully crafted sequence of instructions to the machine in a way it can naturally understand. It really all boils down to a core philosophy from our source material today, which says programming starts with understanding the problem. Code is simply the tool used to implement the solution. I absolutely love that. It's a great reminder that you, right now, already have the human capability to look at a complex system, break it down, and solve it. The code is just the paintbrush you use after you've already visualized the painting. So, what is the very first story you want to tell a computer? I challenge you to start applying that systemic thinking today. Just look around and try breaking your own daily challenges down into inputs, processes, and outputs. And hey, if you enjoyed peeling back these layers with me, I highly encourage you to check out LD TechLab's next explainer on algorithms, where we dive even deeper into how successful engineers architect their brilliant solutions. Thanks so much for joining me today, and keep learning.